The loop, if it is like this, my dear, please, all of you, this is something very important. Now you tell me, like, what is EMF induced in this loop? No doubt, nothing. First, you answer this me.
So AB plus BC is pi r square into alpha.
What about EMF induced across the rod AC?
It will be 0. Sir.
Now tell me, like, is it this loop enclosing any magnetic field or not?
Yes, sir.
Is it magnetic field is varying?
Yes, sir.
Flux varying, the loop is varying. Yes, EMF will be induced or not?
Yes, sir.
Will be induced. That is what I'm asking.
Okay, sir.
Okay. I think most of you are making mess with mathematics. Yashovardhan, the logical thinking is very important. You are not bringing that logical thinking. I said only across AC it will be 0. That's all. So now get ready now. If the ABC is a loop, B bar is varying with the time. EMF induced in the rod in the loop ABC is non-zero, whereas in AC it will be 0. I think this is what our problem is, what we have discussing. Why, sir? Why EMF induced across AC 0? Because everywhere E bar is perpendicular to the length AC. That methodology, if you can catch, it's over. I think I can stop class. There's nothing, no fun in discussing more numericals. Okay, all of you make observation.
Sir, one more doubt, sir.
Yeah.
Sir, why did he tell that it is a non-conducting wire, sir?
If it's conducting, then there'll be ET generated. Then J equal to all Ohm's law will come into picture. Then you can't just define the way we are just finding out potential difference or EMF something. Okay, that just it's like some sort of non-conducting rod. That's simple. If the conducting rod, the electrons will come into picture. The electrons will start moving. Again, so many other things will come into picture. Huh?
Okay, sir.
Yeah, fine. Okay, this is, I think, hope everyone, the last diagram is what I'm concluding. Okay, let's take the, slowly we'll enter into some application problem. I should decrease the size, this one. So just analyze, nothing wrong, say there's nothing, we do learn by mistakes only. But the math should not kill physics. The application of math should not be to that action that you eliminate physics from the problem. And now come for this one. I think this is the best problem where I'm starting. It's there in almost material and books also. Now get into the concept. Read the question once. There's a charged particle is there. Now we know the magnetic field is varying in this region only. Will it produce induced electric field only in the region where magnetic field is varying, or everywhere till infinity? From the axis of solenoid to till infinity, induced electric field will be there. The best sentence is what a teacher is repeating. All of you, you have to write these things in notes. If you don't write, I don't know. There's no future for you. That's what I'm telling you. Some things are very particular. What about induced electric field? The magnetic field is varying. Where the induced electric field will be present? This you tell yourself 1 crore times. Have clarity, because almost all numericals I'm using same diagram. Those who are sleeping, please do awake. Looking here and there, please look at the screen. Where magnetic field is varying here, where all induced electric field is present, from the axis to the till infinity. And how it will vary? First problem yesterday we have discussed. Here it will, the magnitude of induced electric field will increase, becomes maximum here. Outside again it starts decreasing. How to calculate that? draw a circle with respect to center of the magnetic field region. Then there you draw a tangent. Okay, sir, what about the tangent? Tangent I can draw like this also. Tangent I can draw like this also, or I can draw like this also, but it matters a lot. It matters a lot. Then who will help us? The Lenz's law. The magnetic flux, positive flux increases, difficulty positive, EMF induced negative. So how the induced current should be clockwise. So how the induced electric field here will be downwards, increasing, positive flux increasing. d5 by dt positive, EMF induced negative. No. How the induced electric field? So what you are going to do? You are going to draw a circle here. Then how the T-bar should be tangential. So it should be upward or downward here. It should be downward. If it were positive, it should have been upward. So here the induced electric field here at this point will be in this direction. What are the forces? The compression in the spring is asking. Why the compression in the spring all? So here the forces acting on this. Only I can't draw everything. So here the compression, then mg, then QE. Sir, how come this induced electric field, can it act on any system? As slowly we are going for application part. So what is this kx should be equal to? How to calculate induced electric field there? E into 2 pi L pi r square dB by dt. I'll write for your convenient. No, what is this? This should be E is constant at all points. Sorry, this is E dl. S is pi r square dB by dt. This should be 2 pi r, 2 pi L. You have to draw a circle like this. It'll be a circle. So here is what? The DL. Don't measure DL in this direction. E bar will be tangential. So this value of E, you're going to substitute here. This E is now pi will get cancelled. R square 2L dB by dt. Oh, everyone is able to